Hello, my name is Cukurova, and today I will present you my implementation of continuous bag of words technique for natural language processing course at Cukurova University. What is continuous bag of words? It's technique to get embeddings for our words. It's to get the vector representation of some word. And to do this, I use TensorFlow library, especially Keras plugin or module. And my dataset was the fake and real news dataset from the Kaggle. It has really high score, and dataset was quite enough for this purpose. So how continuous bag of words work? We have some context, some number of words, and by this number of words we need to predict the word that should be placed in the middle of this context. And by this we train the model, and embeddings are created. So first of all, let's read our data. It is data frame, and the most important is title column. After this, we clean our data set, prepare it for being tokenized. After this, we do tokenization using sentence piece, and in titles tokenized, we have a list of IDs, which will represent our our actual words. Yeah. After this, what we do is we set window size, so number of words from the left and from the right from our for our context. And as you can see here, we have the context and the label, which should be classified based on this context. After this, we introduce our TensorFlow model. It's simple model with an input layer where the number of input elements is equals to twice as large as Windows has, because we have from the left and from the right a number of equal number of elements. After this, we create embedding level, which is the most important for us, and this will represent our words distinct embeddings. And we are setting here vocab size. It will so our model will train its embeddings only for the top vocab size number of words, because it's not like raw version model. After this, we have two more layers about normalization, output of embedding layer, and averaging the output. And as the output of our model, we do softmax on this, and we get the probabilities of each word to be selected. So based on the context, we get the output is a probability that this word is the right one. And based on this output, we train our model. After training, I run it here. We have accuracy about 17%, but it's quite enough for our purposes for simple model. We get embedding weights, which will be our real embeddings. It's for 1000 elements. Here we can see the vocabulary and what are the most popular words. For our tokens, I selected like several words to understand how close these words are. Bank, Russia, Putin, billion, million, and Obama. After this, I encoded these tokens using sentence piece model pre-trained, and I selected tokens, embeddings for each of these tokens from the embedding weights which we selected above. We normalize these embeddings, and after this we can see that the product by itself is equals to 1. That means that the vectors are normalized. And let's visualize our results. As we can see, the lighter the square, the more similar words are. So Obama, Putin, and Russia are quite similar. Putin and Russia, for example, really similar, and billion and million also similar, but billion and Russia is not similar. So that's all. Thank you.